Today we're going to take a look at section 13.2. This section we're going to look at a couple more transformations. The first one is called a reflection. So a reflection, or sometimes called a flip, is another transformation. It's an isometry. Okay, it preserves, remember what isometry means? Okay, it preserves distances. It doesn't change sizes or shapes of things, okay? So that's what an isometry is. If you have a point P and it's reflected over a line L, and its mirror image is the point P prime. We call that line L the reflecting line. If P is actually on the line, it will stay on the line, right? If it's not on the line, of course, then it won't. So if it's not on the line, if P is not on line L, then L is, let me write this down, hang on. Then L is the perpendicular bisector of P prime. Okay, so let me just kind of give you the image of what that's doing. So if this is line L, and this is point P, and point P is reflected over here, it would be point P prime over here. And if you were to actually connect these two, we would create perpendicular lines, and L would be the bisector of that line P prime. I guess I could mark my perpendicular here. A reflection also reverses the orientation of the image. Okay, so you've probably all had that experience, right, where you're trying to describe left versus right to somebody who's sitting across from you. Your left and my right don't match up quite correctly, right? It reverses the orientation when you do that. So that's what that's referring to, is the reverse of this orientation. Now we're going to talk about constructing a reflection. So one way to construct a reflection is with folding. So you can fold along the tracing or the reflecting line, and using tracing paper then you can reflect the line as a reference point. So you can see the P and the P prime on the side, right? So here's my folded sort of piece of paper, and the image folds over here. Here's P and here's P prime. This would be my pre-image where it started. This is my image where I've ended. And then I have something that's the exact image but flipped on the other side, right? It's the reverse image, if you will, or something like that. It also creates, if you will, a line of symmetry. We talked about that before, right? So that whole sort of created picture, in this case it's a tree, actually has a line of symmetry because that line of reflection created it to be that way on purpose, right? It did that. So tracing paper is one way to get this line of symmetry to create a reflected image. So when you're constructing the reflections on tracing paper, this is sort of a visual imagery of how it happens. So we have the picture on the left. Okay, so you've got not tracing paper, but you've got something with you that's very similar, right? You've got white paper. All of this is actually printed on yours on white paper just like it is on mine. So if you were to fold along the blue line, I know it's blue on my screen, not on your paper, but if you were to fold along that blue line, can you see that the image on the other side gets flipped over to be the image on the second diagram? Okay, not only that, but this diagram actually shows really well what happens if you actually flipped the whole image, that is, the letters that are there as well. So you can see this value A is sort of slanting to the right, yeah? And when it reflects, it's not slanting to the right, it's slanting to the left now, yeah? And the same thing with C. C is actually looked like C, and then when it reflects, it actually looks like C backwards. Same thing with the B. The B looks backwards. The X and the A are a little bit harder to tell because, of course, they don't have as much of a directional sense, but they are slanted in this particular font, so you can tell it a little bit. Okay. Now we're going to look at what happens when we do this on dot grids. It's a little bit trickier, especially trickier when the line of reflection is not horizontal or vertical. So if you have a line of reflection like this one where it's sort of at an angle, first of all, let me make the comment that could you not just turn your paper to be okay with the idea that it could be vertical or horizontal? Are you guys with me on that? The fact that it's diagonal throws our minds into a little bit of a tailspin. But could we move our paper so that that actually looks like a horizontal or vertical? We should be able to do that. Okay, so that's one sort of a comment just off the cuff already. Now, what we're going to do as we reflect is that you want to keep in mind that this reflection is not going to reflect over here, because that would be a reflection around a vertical line, and this is not a vertical line. So it's going to look like this actually reflects down here because of the way that the line is drawn. So I want you to give it a try. If you mess up, it's okay. Hopefully you've got a pencil with you. Draw what you believe the reflection should be for this image. What is this image, by the way? It's trapezoid. Very good. Okay, so draw this reflected image. Do you guys have an image? Okay, so let's start with this point right here. Where does this point land? What is its image under this reflection? Right there. It doesn't move. If it's on the line of reflection, it stays on the line of reflection. Okay, so let's actually do this horizontal line that extends over from it. It's too long, right? Where will this line go under the reflection?
It's going to start at that point and go over all the way to the end.
Like this?
Yeah.
Nope. Good try. It'll go down, actually. That point will reflect down. Oops, hang on, let me get my screen a little bit bigger. Will reflect down here. So imagine folding it along the blue. And of course, my screen is not a perfectly square screen, so it doesn't really look convincing either on the screen that you're seeing. But this is reflected down here along the blue line. Okay? All right, how about then the vertical piece right here? I mean, it should connect to this point down here that we just stopped at. Where will this value, or this line segment go? To the right. It'll go right here. That's not convincing at all. And yet again, let's try this one more time. All right, that's fairly decent. I think that was not third time a charm. I think that was about fourth or fifth. All right, we've got this little piece at the top. This one segment long piece, 1 unit long piece. Where should this go? I better touch this point right here, right? And where will it go? Up. Yep. Sometimes this app is trying to be extremely helpful, and it's not. It tries to connect things that you didn't intend to connect. All right. Our last piece. Where will it be? Yeah, it'll close up my figure, right? Like this. Again, the scale looks kind of funny because the way the projector is projecting. But on your paper, if you were to fold along the blue line, the line that's blue on my screen, you should have the same image on both sides. They should match up. Is everybody good with that? So, Amy, the image that you were creating would have been a vertical reflection. If the line had been vertical here, like the blue line had gone like this, then this piece would come over here, just like what you were suggesting. Now, what would we do, or what would happen if the reflection actually crossed over the blue line? Like if the original, not the reflection, but if the image, the pre-image, the very original picture was sort of like if the line of symmetry was cutting through it. Well, then the line of symmetry.
The other part would just be on the other side as well.
Yeah, it would reflect around it, right? We would still have the pre-image. If the pre-image were cut through by the line of symmetry, the image would be as well. So it would sort of, and I think maybe we have an example of that. If we don't, I'll create one before we're done today so you can see what I'm referring to. I can't remember at this point now. Okay, let's take a look at the Cartesian plane when we're actually doing these reflections. So if you want to draw a grid for yourself, an XY grid, to think about what happens to the XY ordered pairs, okay? So if you have an XY ordered pair. I'll draw a little bitty one down here at the bottom. And we're just going to pretend that we have this point right here, which is called X, Y. Okay? And we want to talk about reflecting, oh, they don't use X and Y, they use A and B, so we should too. Let's change that. A, B, better. And we want to reflect these over different lines. So reflecting it over the x-axis is down here. If I reflect this image AB over the x-axis, it's going to reflect down. A and B, one of them is going to stay the same. Which one? B. B or A? A will stay the same because A indicates how far left and right we've moved, right? So if I reflect it down, that doesn't change how far left and right I move. So down here, in other words, is where I am. I still have the ordered value A as my X value, the ordered pair value A. But what happens to B? It becomes negative. That's the one that changes signs. So my first blank here is that the AB point changes to A negative B. What if we reflect over the y-axis? So my y-axis is up here, my vertical axis. I'm over here now, right? At least roughly. Pretend. Here you go. What is this pair? The B stays the same, right? It's the same height. What can you tell me about the x-coordinate?
Negative.
It's negative A. The distances have to be preserved, right? So if it's A right, it's negative A left. Okay, so this is the point, negative A, B. All right, the next ones are a little trickier, and I'm going to draw my picture again to make sense of it because I have drawn this in such a way that's going to be very unhelpful. So, you guys ready? Okay, I'm going to erase my orange. This one's going to want us to reflect something over the line y equal x. So the line y equal x is this line. Are we good with that? Kind of like the diagonal line we did on the last slide. I just didn't want my point AB that I had drawn originally because it kind of looked like it was already on that line, which is extremely unhelpful because I reflect and I don't change anything. So here's my point AB now. So if you can imagine, this distance has to be preserved. So that looks like a horizontal distance now. When it gets reflected, will become what's looking like a vertical distance, correct? So the image sort of looks like this. You are so correct. Well done. This image is BA. It switches because of the preserving of the distances. This is BA. Now I'm not going to draw the next one because I think you can probably piece it together. What do you think then would happen if you switched it over x or y equals negative x? Yeah, it would just change the signs from the last step, right? So I'd still have B and A, I just have negative B, that is the opposite sign of B, and the opposite sign of A. Okay? So, using that information, it's your turn. What will you get if you reflect the point 2, negative 3 across the x-axis, the y-axis, the line y equal x, and the line y equal negative x? You can draw a picture if that's helpful. You can use the sort of, I don't know, formulas or equations that we just wrote down in the last step if that's helpful. But go ahead and fill in those 4 values. What'd you guys get for the first one? The x-axis. 2 what? 3. Sounds good. Is everybody good with that one? Okay. What'd you get for the y-axis? Negative 2, and then what? It would be negative 3. Remember, we're reflecting the original point, and the original point had a y value that was negative. So we'll keep that one the same. How about C, reflection along the line y equal x? Negative 3, 2. So we switched to where the x and y are located. And the last one? 3, negative 2. We just take the previous answer and change the signs. Okay, very good. All right, another one for you to try. We have several figures here. They're all isometries, and we're going to describe how they have gone from one of the images, the pre-image, to the image. Tell whether the figure in each pair are related by a slide. That's the same as a translation, remember. A flip. That's the same as a reflection. Or a turn. That's the same as a rotation. If it's a turn or a rotation, you have to describe how. You know, is it moved clockwise or counterclockwise and how many degrees? Okay? So give this one a try, 1 through 5. And when you're done, I'd like for you to sort of compare your answers with someone next to you to see that you have the same ideas along the way. Okay? Okay, you guys kind of all sort of settled, so you must be in agreement enough that we can talk about it. What'd you get for number 1? A flip. It's a reflection, right? If you were to draw, could you draw the line of reflection in there if you were asked to? Yeah, it'd be a horizontal line, right? So there are 2 possible answers for number 2. And Jacqueline and Amy weren't so convinced when they were trying to decide between them. So what did your group get for number 2? Turn. Okay, it could be a turn. If it's a turn, Whitley, what did you just say that the turn was? 90 degrees. And it looks like it's going from the pre-image, which is the orange piece standing straight up, down. So it'd be a clockwise rotation, right? Okay. Did anybody get something different? I know somebody did. Did anybody besides Jacqueline get something different?
Flip.
It is a flip as well. What would it be if it were a flip? Jacqueline, Elena, whichever wants to talk.
The center point, you create a diagonal.
Yeah. What if you drew basically like a line y equal x through this point right here in the middle that they have in common? Do you see it?
Yeah.
It's a reflection as well. This one has 2 possible answers. It's a reflection over this sort of line y equal x through here. Good. What'd you get on 3? Slide. Right? So slide makes it look like you've taken the image and you've just, shifted it, right? How about number 4? Turn or flip. So let's talk about the turn first. Okay, so what did you have for your turn, Amy?
I had 180 degrees.
Okay, and it would be around that point where they have in common in the middle, right? Okay, good. And you could either say clockwise or counterclockwise. It wouldn't matter, right? Okay, so tell me what you're thinking about flip, Elena.
Again, the points that are in common, you create a diagonal.
Okay, so you would do a diagonal like through the blank space? Do you mean like this?
Yes.
Okay. So if we did the line through there, would it flip over?
No, that's wrong.
I think it would work. I haven't thought about it that way. That's why I'm wanting to double check myself. These guys are saying no, so let's double check. No, I don't think you're going to get the rotation in the right direction. It won't be oriented right, will it? Yeah. I don't think that one's going to work. I think that one is actually going to have to be a rotation on that one. 5 is a little different. I heard some interesting comments as I eavesdropped a little. What is going on number 5? Maria and Paul.
The flag is it's like a picture of a flag and it's been turned.
Okay.
But I think Maria's right because with Paul, if you turned it, the flag would be pointed up. Like
They're both correct. It just depends on which way you're turning.
It does. They both are correct. It depends on which way you're turning. So Maria, let's say that the orange flag standing straight up is the original. Okay, that's the pre-image. So Maria turning it 90 degrees would mean, how is she turning it? Counterclockwise, right? She's turning it counterclockwise. Is everybody good with that? Maria is counterclockwise, turn 90 degrees. If we are doing Paul, what's Paul doing? He's turning it clockwise, 270 degrees. And you'll notice, what's 270 plus 90? 360. That's not I mean, like, that matters. That would have to be the relationship between the two angles if those actually worked for both of them. So they're turning it different directions. The direction matters, right? If it's a clockwise turn or a counterclockwise turn, it creates something different. All right, we're going to talk about actual mirrors now. And we're going to do something with mirrors, which is a little something different next time. Reflecting light off a mirror, and there's an image on the next screen that we'll talk about with this a little bit more after we fill in the blank here. An angle of incidence. So the angle of incidence is the angle that's formed by the light that hits the mirror, so the incoming ray, and the line that's perpendicular to the mirror. And then the angle of reflection is the angle that's between the reflected ray, right? Because whatever comes into the image of the mirror goes out from the image of the mirror as well. That outgoing ray and that perpendicular. And the angle of incidence and the angle of reflection are congruent. So that's what goes in this blank right here, is congruent. And as is so often the case, a picture will explain all of that so much better than the words, right? So let's look at the picture. All right, so imagine down here, this is your mirror. Okay? The light, here's my sun up here. In fact, I'll even just hold tight. I'm going to do something. There's the sun. See? Just like that. I've got a sun on my screen, and it's shining some light. Right? It's shining light like this. And that light forms an angle, and the angle is formed with the perpendicular. So here's my perpendicular line to my mirror, the orange one. And the angle of incidence is the line, or is the angle, excuse me, that is created from the incoming ray and from that perpendicular line. And then the reflection is happening over on this side. So we will make our reflection, we'll make it green just for fun. So here's my reflection over here. So that reflection bounces, the ray bounces off the mirror, reflects over here. And that angle that it bounces in direction of creates an angle of reflection that's congruent to the original angle. All right, these two angles are congruent to one another. All right, there's one more type of isometry. One last one, and it's in this section. The last isometry is called a glide reflection. A glide reflection, another form of isometry. Remember, isometries preserve what? Distance, which means shape and size, right? So it keeps the shape and size of something the same. So a glide reflection consists of a translation. What is translation? A shift. It's a slide, shift or a slide. Followed by a reflection. That's a flip. We just did that one, right? A reflection. And the reflection has to be in a line parallel to the slide arrow. So the footprints here are an example of a glide reflection. Okay? So let's go to the next slide, and it'll talk a little bit more about the glide reflection. All right, so there's the original image, the foot.
You can't even see the third foot on ours.
Oh, you can't? I barely can on mine too, yeah. All right, so you can see from the pre-image, right, the sort of hollowed out foot, it's translated to the blue foot, correct? And then it's a reflection across the line that's parallel to the way that it was translated. Okay, so we have to have that line parallel for that to make sense. So the translation line, which is the dotted line up here at the top, and the reflection line down here are parallel. It's a slide and a flip, exactly. And it's called a glide reflection, glide or slide, right, idea, and then the reflection is the flip idea. All right, and so I couldn't show you a picture like this without showing you the poem that most of you've probably seen before, but we're going to read it anyway. All right, so if you haven't seen this before, you're in store for fun. Footprints. One night, a man had a dream. He dreamed he was walking along the beach with the Lord. Across the sky flashed scenes from his life. For each scene he noticed two sets of footprints in the sand, one belonging to him and the other to the Lord. When the last scene of his life flashed before him, he looked back at the footprints in the sand. He noticed that many times along the path of his life there was only one set of footprints. He also noticed that it happened to be at the very lowest and saddest times of life. This really bothered him, and he questioned the Lord about it. Lord, you said that once I decided to follow you, you'd walk with me all the way. But I've noticed that during the most troublesome times of my life, there's only one set of footprints. I don't understand why, when I needed you most, you would leave me. The Lord replied, my son, my precious child, I love you, and I would never leave you. During your times of trial and suffering, when you see only one set of footprints, it was then that I carried you. It's a good one, don't you think? I think so too.